position, velocity, acceleration, and speed. These are the four things. Position, velocity, acceleration, and speed. You need to know them in what is called rectilinear motion. Rectilinear motion just means movement in the rectangular coordinate grid. Like, things are going to go left and right, or they're going to, or they're going to go up and down. If you're in calculus AB, rectilinear motion just means things move left and right, or they move up and down. Never do they do both at the same time in calculus AB. Oh, but wait, you all are in calculus BC. Not only do they get to go left and right or up and down, sometimes they're doing both. Sometimes your particle gets to move in all sorts of crazy directions. And because...
It's not a function.
Indeed, you're right, it is not a function, but we're in calculus BC. We're going to be okay with particles moving in like whatever way they want to do. They're particles. They can move awkward around the camera. But in rectilinear motion, this is like movement in the rectangular grid. In AB, left and right, or up and down, never both. In BC, sometimes both, and wait for it. In BC, we also go beyond rectilinear motion. We look at polar coordinates. You guys remember polar from pre-cal? Probably not at all. Yeah, we're going to go back to polar. I don't know. I don't expect you to remember much of anything. I'm amazed you find. I'm amazed you find the room every day.
Me too. Me too.
And wait for it. And we get to talk about parametric curves again in calculus. It is wonderful. These are huge things in BC. So if anyone's going to like transfer to a new school or drop the course, all that's going to happen around February and March. So it'll be good until then you might want to get out. All right.
Can we stay on derivatives?
Can we stay on derivatives? Yes, dear, we can. Yes, we can. All right, Carmen, I need your assistance. Shut up. I am going to either engrave your calculators this period, or I'm going to ask you at the end of the period to put your initials and student ID on a Post-it note, put it on the calculator and leave it on my desk, and they will get personally engraved for you. And then you'll just stop by at the end of lunch and pick them up. Pretty good?
End of our lunch, right?
At the end of your lunch, they will be ready. Can you help me remember this? Okay, good. All right. Let's get rocking and rolling. I need you guys to turn to page 44. The physics begins now. The good news, this is all going to be calculator active. Aaron, I need you to go on back. You're going to be driving. Oh, you got this. All right. Here's what I want you to do. Take a minute or two. Read through this problem. Get your calculator set up. Do all the things you would do if this showed up in the test we're having next, oh yeah, Wednesday. Enjoy the ride. We'll talk in a bit. Welcome to High Expectations.
Yes, this I'm talking about.
This is great. I guess I want to keep going.
This is coming.
The velocity is travel along. And we want to put the function. That function.
Well, Les and David, you guys are working on this problem, getting it set up. The only person not doing that right now is Aaron, and it's totally my fault.
It's cool.
Of course, no idea what the kids at North Central are doing. Okay. Yes, please. Let me draft. Jose, Victoria, and Nathan need to attend a fundraising event for the Maverick Nation. Yay! Rather than taking their own cars, they decided to borrow my vehicle for the afternoon. Don't ever try this.
What?
First of all, my car doesn't go very fast. Alright. The velocity as they travel along I-10 can be modeled by this function, 10 e to the square root of t times the sine of t on the interval 0 to 7. Nice job, Aaron. You know that the graph does, your calculator doesn't graph in terms of t, we graph in terms of x. You hit enter. We get a really ugly graph. One of the things that needs to be super clear from this point forward, when they give you a domain restricted window or domain restricted function, set your calculator to match that domain restriction. So your domain restriction is what, 0 to 7? Okay, not 107, not 107. 0 to 7. Okay, anybody find a good Y min Y max yet? Negative 100 to 100. Alright. Oh, nice graph. Okay, I definitely want to make sure, number one, that your graph only goes from 0 to 7. They've told you in the problem this function only works from 0 to 7. So don't go anywhere else, just 0 to 7. In terms of the Y min Y max, you're going to have to play around with that to make sure that you see all the action. Give me a quick thumbs up if everybody's good with the graph. Giselle's good, David's good, Andrew, you're good. All right, so sketch the graph. So, just transfer it over to your paper. If you want to use the colors, there should be markers around you somewhere. All right. B. David, you said you didn't do AP Physics, right?
No.
Okay. So B, when is the velocity increasing? What would you be looking for, David?
Well, I'll be looking at going up.
Where? I'm sorry, what?
Alright, what f of x? What b of t from?
Good. This is not f of x, so you want to be careful, right? Just like we had like the whole ff prime thing. Now we've got t and v of t, and t is time. What are the units for time in this problem? I forgot.
Hours.
Hours. And on the y-axis, the units are miles per hour. All right, so using the calculator, when is the velocity going to be increasing? What I heard David say earlier, the velocity is going to be increasing when the graph is going up. Right now we're not even really doing much calculus. This is just like calculator stuff. So my graph is increasing. I can see it starts increasing at 0. Where do I stop increasing?
1.9.
Is that like this guy over here?
Yeah.
Okay, Aaron, I want to make sure that we're all developing the good calculator skills, right? So we're going to go analyze graph. And what you need is the maximum.
1.93.
0, you said 1.92. I do not like that answer.
917.
In AP Calc, always answers must be accurate to 3 decimal places. If your calculator is not displaying 3 decimal places after the decimal, let's fix it right now. All the friends okay? Yep. So from 0 to 1.917. Now, am I increasing at 1.917?
No.
I'm not actually increasing, so you would probably want to put parentheses. But remember the conversation we had the other day? In AP Calc, you are allowed in the world of increasing and decreasing to say, let's, even at that place, it's we're going to include the 1.917. Sorry, that was awkward. Now, is that the only place where we're increasing?
No.
We're also increasing from, what, like down here, so now we need a minimum. So let's make sure we can get a minimum.
4.9.
Okay, remember, 3 decimal places. If it's not 3, I don't want it.
4.934.
Oh, 4.934? Okay, everybody good with 4.934? All the AP Physics friends, if you want to go faster, please feel free to go faster. 4.934 to 7. There was no part of that first question that was a calculus question. This was more calculator question. So, Celeste.
The brackets don't matter, right?
In an increasing, decreasing conversation, brackets or parentheses are okay. I usually embrace the brackets. I like using the brackets, but you can go either way. All right, C, here's what I'm really interested in. I'm going to stop talking for a little bit. Evaluate V of 2 and dV dt at t equals 2. So find those values. Then when you're done, using correct units, explain the meaning of each answer. We'll talk in a minute.
So you're already at fixed 6. So that's good. And I'm gonna make them false. Oh, I know at that point your might also need to be here at the top level settings, document settings, no.
All right, Eileen, what do you have for me for V of 2?
37.42. 402.
37.402. Is everybody okay with 37.402?
See.
And Aaron, were you able to get dV dt at t equals 2? Okay, somebody help me out. What am I even asking for here? dV dt at t equals 2. This is the derivative. How are we going to get the derivative? Stephen, help Aaron get us to the derivative.
Go to menu,
Menu,
click on analyze graph,
analyze graph,
click on that. Right
click
there.
on dy dx.
And then
It asks for the position. Where do we want the derivative? 2. So just type in 2.
That's it.
That negative 3.894?
Yeah.
Yeah, if you want to like click it and move it.
I just highlight it right there.
Okay, negative 3.894. Negative 3.894. In terms of coming up with the numerical values, is everybody okay? Okay. I need a sentence for the first one. V of 2. What's the sentence? Go for it.
At x equals 2.
At what?
At t equals 2.
At t equals 2.
The velocity
Right, if I want to make it even better, like at t equals 2 hours maybe. Okay, the velocity.
of v of t equals 37.
Because you're already using the word velocity, I'm not going to overuse the v of t, right? At t equals 2 hours, the velocity
Is 37.402 miles per hour.
37.402 miles per hour. Love it. Now, the one I'm much more interested in is the sentence for dV dt at t equals 2. This is the big one. You want to take it?
At t equals to the
Hours.
the velocity is changing at a rate of, it's decreasing at a rate of.
Okay, at t equals 2 hours, good save. I heard you say the velocity is changing. Be specific. Hold your thought just for a second. The velocity is decreasing. Keep it going.
At an average rate of 3, at a rate of,
Right, not average rate. That's like Algebra 2 pre-calculus. At an instantaneous rate is fine. At a rate of, you're doing a good job, Holly. Hold it together.
3.894 miles per hour.
Miles per
Hours per
hour.
hours per.
the velocity, the way I always think about these derivatives here, dv is being measured in miles per hour. T is being measured in hours. So the units here are miles per hour per hour. How many of you guys honestly had that sentence? Not nearly as many as I hoped. Okay, Stephen, what was your question?
Oh no, I was gonna answer.
Oh, you were going to answer. All right. Everybody good? Miles per hour per hour. Has anyone seen these units before?
Yeah, that's for
You've seen them in AP Physics. You know that these are the units for acceleration. Acceleration, if we really wanted to go back to the world of AP Physics, acceleration is asking for, ooh, nice! I didn't see that coming. Okay, acceleration is a measure of how velocity is changing over time. So when I take the derivative of velocity, you know what you're really finding? This is acceleration. This is the acceleration at time t equals 2. Acceleration at t equals 2. So if I ever ask you, hey, what's dv dt, you know I'm really asking about an acceleration question. But now if I were to say do something crazy like in part D here, part D, determine the acceleration of the car the second time the car comes to rest, what am I really asking for? I want the derivative of the velocity graph. You have the velocity graph already, but I want the derivative of the velocity graph at a very particular time. Good luck with that. Keep thinking about that. We'll come back.
Yeah, what is this one?
Determine the second time
And then it's the maximum or minimum. So when is this? Yeah, we're looking for acceleration.
Wait.
So I want the acceleration the second time the car comes to rest. And I'll say technically, there's two answers that I'll accept here. When does the car come to rest for the second time? You guys point in your graph. Where does that car come to rest the second time? Interesting. Interesting. I'm seeing all sorts of things that I wasn't guessing was going to happen. So some people, hold on, Aaron. Some people are saying over here. Some people are saying over here. Some people are saying over here. And some people are saying over here. These seem to be the four places that people are pointing to. The question is, what is the acceleration the second time the car comes to rest? If the car has come to rest, the thing that you know about the velocity?
There's a horizontal tangent.
You have come to rest. Your velocity is 0. Yep. Right. If I'm moving forward, I have positive velocity. Sorry, North Central friends. If I'm walking backwards, I have negative velocity. If I am at rest, I have no velocity. I'm not moving. I need v of t to be equal to 0. So, is everybody okay? It's not going to be this one?
No.
And it's not going to be this one. Now we're going to have a little bit of an argument here. This one or this one? The second one? Okay, if you're a really careful reader, I would say this, you haven't come to rest here. You are starting from rest here. This is the first time you come to rest. This is the second time you come to rest. So what we need, first of all, you need to know the root at this point. So we need the value, and I want to show you some calculator skills. Okay, so you don't want to trace this time, Aaron. You want to analyze graph. And you want the 0. Yeah, there you go. There you go. It says 6.283. So first of all, I'm going to make a little note here. T is 6.283. Now, a couple of options here. What you want is the acceleration at 6.283. The acceleration at 6.283 is the same as I'm going to use v prime, the derivative of the velocity at 6.283. One way that you can do this, you've got the graph in front of you. This shouldn't be a big deal. Menu, analyze graph, find the derivative, and find the derivative at 6.283. This is like a way. What did you get?
122.626.
122.626. Anybody else 122.626? Okay, 122.626. Okay, 122.626. I agree. That's a way to do it. Let me show you another way to do this. Okay, I want to leave the graph screen, and I want to go over to the calculate screen. So, Aaron, the way you're doing it, you're going to add another page. So, Control Doc. Control Doc, add a graph. Okay. Oh, no, I'm sorry, I didn't mean to do that. Sorry.
Oh, but didn't you have a calculator?
Yeah, add a calculator. My bad.
Okay, hold on.
So, Control Doc, add calculator. Okay, you can find derivatives on this screen as well. Hit menu. Trust your instincts. Calculus. Trust the instincts. Numerical derivative at a point. Now, it's going to say your variable is x. What's the value? 6.283. And you want the first derivative, but oh, how convenient. It can do more if you need it to. Then hit OK. Just first derivative, though. First derivative, hit OK. Look at this beautiful notation. The calculator knows the ddx notation means derivative. You just have to tell it, what do I take the derivative of?
Bar
Oh,
Right, just type in f1 of x.
oh, this is perfect.
f1, and it's in bold, so the calculator's like, oh, I know what you're talking about. f1 of x, though. It needs to be a function. Okay, Aaron, arrow up. All right, let's arrow down. Arrow. No, you're not listening. So don't listen to me. No, that's, I want to show you to be smart. I know you don't want to be smart. Arrow up so it highlights and hit enter. It's like the copy paste feature on your computer. Big. So open parentheses, x, close parentheses.
So much things today.
I know, I try. Enter 122.626.
How'd you do this?
Magic.
Okay, 122.626 units, miles per hour squared. Everybody's okay? Everybody good? Okay, part of what I wanted to build into this lesson specifically were some new calculator skills that maybe you haven't seen before. All right, I'm going to stop talking for a little bit. I'm interested to see what you guys can do with parts E and F. We'll talk in a little bit. E and F.
Are we in degree mode?
Never. In calculus, you are only ever going to be in radian mode. Andrew, you, my friend, are going to have a tough challenge. Because you're in AP Physics and in AP Calc, you're going to have to know to switch between AP degrees and radians. We are only ever in radian mode here. If you're in degree, your answer's going to be wrong. All the time.
Okay, how about you couldn't do
All right.
Dang it, the graph was away.
All right. I need velocity negative and acceleration positive. Velocity negative and acceleration positive. How would I ever figure that out on the graph? I hope the velocity negative part is the easy piece. All right, velocity is negative over here.
I was right.
Acceleration positive, though, means something. It means something about your velocity graph. we know about the velocity graph? If we've already established that acceleration is the derivative of velocity. So if acceleration is positive, that stands to reason then that what we're saying is the derivative of velocity is positive. But if the derivative of velocity is positive, then what that tells us about the velocity? Uh-oh. Acceleration and derivative of velocity are the same thing, right? What I have in front of me is the graph of velocity. If the derivative of the velocity is positive, then the velocity graph, the word I'm looking for here, uh-oh. Derivative of the velocity is positive, so velocity is increasing, decreasing, increasing. But I thought I heard a lot of people say decreasing. So what I need is velocity negative and velocity increasing. Velocity negative and increasing is going to happen from this guy down here all the way up to the root. Okay, what are those values going to be? So Aaron, minimize, what is that, 4.934? 4.934, and then what I heard was we already know what the other root is. The other root is going to be 6.283. Now, I've got my picky pants on today. We are talking about velocity being negative and acceleration being positive. We're going to run into some problems. If you're tempted to put brackets here, you cannot put brackets. If you put brackets, you're saying here at the root, the velocity is negative. And here at this root, the velocity is negative. And the lie? It's neither. Like, you're at rest at both of these places. So if you really want to put the picky pants on with me, you really need to have parentheses there. I want to be really, really careful. Everybody good? All right, F. Use the graph of the velocity. Sketch the acceleration function. I want you to do this first by hand, and then let's see how good we really are with the sketch. I want the acceleration. I want you to sketch it first. Sketch it by hand, right? The acceleration is the derivative of velocity. Exactly. Like, so all those skills, they're coming together in the world of physics. If this is F, give me F prime. Andrew, help me out here. If we know this is the graph of the velocity, what I want is a sketch of the derivative of the velocity. Are there any things you know for sure about that derivative graph?
The increasing from 0.
Yeah, the velocity graph is increasing from 0 until we get to this point, right? So the acceleration graph? It's going to be above the x-axis. It's going to be positive. Giselle, give me something else that you know for sure about the acceleration graph. Something that you know about the velocity graph. What does it tell you about acceleration graph? Right, acceleration is the derivative of velocity. So tell me about derivative things here. Andrew said when the velocity graph is increasing, the acceleration has to be positive above the x-axis. So something else that you know for sure. When the velocity is decreasing, the acceleration is going to be negative. But the really important things I would start with if I was going to generate the graph. Celeste, what would you start with? Right. Horizontal tangent line over here. Horizontal tangent line over here. That means I've got a root, and I'm going to have a root over here. The red is for my acceleration graph. Now everything else kind of maybe starts to make more sense. You're like, oh, positive, negative, positive. That's my sketch. Just a quick sketch. I'm looking for roots. I'm looking for, are you positive in the right places? Are you negative in the right places? That's a great sketch. Now let's get like the real sketch here. Oh, nope. My bad. So the red is acceleration. I need the speed graph. So I'm going to pick a different color for speed.
Wait, speed is, speed is given.
Acceleration is the velocity's derivative. Speed is something else. And given all the AP physics folks in here, I'm not going to tell you what speed is. You know what the speed is. You guys are like, maybe last year I did. Speed. There's something that you need to remember about speed. I heard somebody say speed's a scalar. Yes, true. There's something else that would be really helpful to keep in mind about the speed. I'm not doing this for my health. There's something really important to remember about speed and its relation to velocity. Carmen, help me out here.
Speed is the absolute value of velocity.
What? Speed is the absolute value of velocity? Maybe that's why I've been doing this for the last 2 minutes and my arms hurt now? Speed.
I thought you were talking about protection line. Vertical tangent
You're
line.
like, speed has vertical tangent lines, it has 2 of them? Speed is the absolute value of velocity. So yes, please write that down. So if speed is the absolute value of velocity, well, let's figure this out then. Speed's the absolute value of velocity. The blue is my velocity graph. The only difference between the speed graph and the velocity graph, because speed is the absolute value of velocity,
Can only be positive.
can only be positive. It could be 0. Speed can be 0, so be careful. So how does this part of the graph change? Right, this part of the graph, when the velocity is positive, does not change at all.
Point at that.
There's going to be a cusp point over here, because what's going to happen, this part down here now gets reflected up. That may not have been a great reflection, but the black here is your speed graph. So you have 2 cusp points.
So you take so how the velocity graph looks, everything that's negative, you flip it above.
Exactly, because speed is the absolute value of the velocity. So anytime the velocity is negative, you're going to reflect it up over the x-axis to get the speed graph.
Thank you, Carmen.
Thanks, Carmen. Aaron, you're good? Everybody's good? All right, H. I want to know whether the speed graph is increasing. Where's the speed graph increasing? Give me some intervals. And then I want to grow your calculator skills one more time.
Yo.
Yep.
Mine's on the 3, don't have like 2 over down.
Okay, so here's the thing. I would encourage you all to not use the document side. Scratch pad is going to be fine. Calculating graph is everything that you need. Usually we don't run into problems. So memory settings, that I think overflow mode, that's the problem. So fix, at least fix 3 of those. So we got default. Or we're going to cancel it. Yeah, that's okay.
I did that.
Yeah.
I did that.
Okay, cool. All right. Using the speed function, identify the intervals where the speed is increasing. Speed is increasing from 0 to 1.917. Easy peasy. Speed is also increasing from wherever this root is. Is this 3.14 or 159?
Yes.
Otherwise known as pi, up to where we have a maximum. Where's the max?
4.93.
4.934 maybe?
Yeah.
Everybody okay?
Go with that.
Everybody good? Now here's the thing. If you have the speed function in front of you, it is easy to answer this question. Right? Because you can see it. You're like, oh, going up. There's one more deep connection that I want to get out of you guys. And I'm going to get rid of the speed graph. Yep. You don't need to do that, but I want to get rid of the speed graph.
Great.
Because what I want to do is have some conversation about other things.
Oh.
Other things. Acceleration is the derivative of the velocity. Speed is the absolute value of the velocity. In part I, the question is now using the velocity function, where is speed increasing? Speed is increasing. You guys have already told me one of the intervals was, what, from like 0? 1.917? What's the velocity function doing on this interval? There's two things that are happening here. The velocity is positive, and the other thing? Velocity is increasing. Another interval where the speed was increasing. Was that this next one?
Yeah.
Think about that speed graph. I know I took the speed graph away.
Yes.
But the speed graph is the absolute value of the velocity from 1.917 to, what was that root, 3.14159? What's the speed doing here?
Decrease.
Decreasing. Where's the speed increasing again?
3.5
From here
to 4.
To the minimum.
till the minimum. So here, now the way I would describe the velocity graph, we could say the velocity now is negative, not positive. Velocity is negative here. And the other thing we know about velocity? Decreasing. On these two intervals, speed increases. Speed increases. Okay. On the other two then, obviously, speed decreases. Okay, there's this one last connection. Let's see if we can get this right. Okay, on the decreasing interval, if I'm describing velocity, we could say velocity is positive and velocity is decreasing. Over here I can say velocity is negative and velocity increasing. Okay? So let's see how well we can do with this. Okay. If the velocity is positive and decreasing, what do we know for sure about speed? If the velocity is, what did I say, positive and decreasing, what do we know about speed? Velocity is positive and decreasing. Let's get some hands on this. Velocity is positive and decreasing. I see 1. I see 2. Velocity is positive and decreasing. Velocity is positive and decreasing. Stephen, what do you know?
Speed decreases.
If velocity is positive and decreasing, speed decreases. Okay, what if velocity is negative and increasing? Velocity is negative and increasing. David, what do you know? One more time. Speed decreases. Love it. All right. Velocity positive and acceleration positive. Now I'm getting mean. Velocity is positive and acceleration is positive, and you're like, but wait, coach, no, you didn't write those notes. Yes, I did. Velocity is positive and acceleration is positive. Another way to say that. Velocity is positive and increasing. So speed is increasing. Everybody good? All right, put your notes away. Don't look over there. All right. Without looking at the notes. Without looking at the notes. Let's see what we can do here. Okay, velocity is positive and acceleration is negative. Velocity is positive and acceleration is negative. That's 2 out of 11. 3 out of velocity is positive and acceleration is negative. Draw it in the air if you need to. Velocity is positive. I'm above the x-axis. Acceleration is negative. What does that mean about the velocity? It means decreasing. Ile, what does that tell you about the speed? Speed is decreasing. Velocity is negative. Acceleration is positive. Velocity is negative. Acceleration is positive. I know, I see Yeah. Good. I don't even care what the answer is. Okay, velocity is negative. Acceleration is positive. What do we know about speed? Aaron? Velocity is negative. Acceleration is positive. Velocity is negative. You're below the x-axis. Acceleration is positive. That means velocity is increasing. Your speed graph, because it's the reflection, decrease. It's actually decreasing. Okay. Yeah. They're not very aerodynamic. Okay. Velocity is positive. Acceleration is negative. Velocity is positive. Acceleration is negative. Velocity positive, you're above the x-axis. Acceleration negative means velocity is decreasing. So speed is decreasing. Okay, anybody need an easier way to remember this? Do you know an easier way to remember this? Go for it.
Basically, it has to be positive. Well,
Oh, I stopped listening. You said it. I stopped.
I mean, V of t has to be positive, and V of t has to be increasing for it to be increasing.
Okay, V of t is positive,
And V of t must be increasing.
and V of t has to be increasing, but that means acceleration is positive. Where's the other place where speed is increasing? Over here. The velocity is negative, and the acceleration? Negative. Easy way to remember that? If velocity and acceleration have the same sign, the speed is increasing. On this interval, your velocity is positive. Your acceleration? Velocity is decreasing, acceleration is negative. Over here, velocity is negative and acceleration is positive, and the result? Speed decreases. So the easy way to remember this, Celeste, easy way to remember this? David?
If the velocity, if V of t and acceleration of t are both positive, that means speed decreases. And
Wait, one more time?
if V of t
Yeah.
is positive,
Yeah.
and acceleration t is positive, increasing.
Speed is increasing. Speed. If velocity and acceleration are both positive, speed increases. Even better than that, though. The other time where speed increases? When they're both negative. So one way to pull all this together, Lewis?
When they both have the same sign.
I know it's not it, but you went with the plural version, when they.
When V of t has the same sign, speed is increasing.
When the velocity and acceleration have the same sign, speed is increasing. When velocity and acceleration have different signs, speed is decreasing. We're good? Perfect. That's what I wanted to get to. All right, so we've got about 6 minutes left. Wonderful. We hit all the physics that we needed. You guys are going to be all set for the homework. Calculators. Let's take out a Post-it note. I need your, perfect. Yeah, Aaron, you're good. Thank you so much for all the work you've done for us. Okay, on your Post-it note, your initials and your student ID. If you want some other number, I'm not going to know. I am not going to draw gang symbols for you. I am not going to engrave important formulas on here, and you're like, well, Mr. DeRozier did it. It's not an honor code violation if it's him, right? Okay, when you're done, let's go pile those up on my desk. Since you no longer need your calculators for the last 5 minutes, what I want you guys to do is on page 43, work on your sketching skills. Page 43. I've given you a very Maverick-centered graph here for M. Hold on. I want the graph of M prime, and I want the graph of big M. See what you guys can do with that. Celeste. Hit me.
Okay, so from here, from 0 to 197.
Speed will be increased. Speed.
Because velocity and acceleration is negative. Speed graph.
43.
Yeah. Okay, you got this?
Also, calculator.
Yeah. Yeah, I might have put yes. For you, I might put PC.
I'm unique.
Oh, both are so unique. And very often the same ways though, so I don't know if that's still unique.
First increasing,
Alright. Sine.
and then it's decreasing.
What? This is not a tattoo parlor.
So is that enough?
Okay, this is your calculator, this is the one not reading,
No, it's not 1
but it won't.
The line is 1
Yeah. That's what lost me. Because I couldn't fix
Yeah,
that.
it shows that it's in radian mode, but if I actually do a calculation, it's in degree mode. Ah, I fixed it. I did.
Good.
Calculator.
Where did you go line here?
It's straight lines.
I was just over there. Thank you for helping me hit my 10,000 step goal. Wait, what are we talking about? Okay,
But then
little m has a cusp point, so m prime.
This would have
M prime gets the whole.
that's the answer they reveal.
Yes.
Oh, it's a way.
Whenever you have a cusp point, your derivative cannot
Dude, I didn't
be
see
contrary.
Alright, so basically.
It wouldn't let me, like, I would
Oh,
use race meters, put in calculating degree.
Oh, I get you,
You don't think it's such a good
Probably not.
Wait.
Oh, Polymon, I thought you were calling me over. I was about to shut up this dirty rag in your mouth. He's moved far away. Oh, good, you're on that.
I mean, it's negative M
No.
X.
They're all like,
M,
right?
M.
Alright, so you know, okay, so
Increasing and negative, so big M.
y equals absolute value, right? Which is the,
Pause.
wait,
Pause.
the derivative of that is y equals.
Little m is increasing and negative. So the antiderivative would go up. Would have to be concave up.
This
is equal. Okay, how we go? Nice.
So that's not
So
right
it's
off.
concave.
Alright, so is this for me? No, it's already been engraved. Perfect. Okay, you have it engraved? We're good? Alright, North Central, see you later.